All right, 1.6 is a big night. I hope you're feeling ready to go because it's it's fractions, which are always problematic, huh? So it's a bunch of fraction stuff. I know we started it, didn't we? Let me run over it again. I just think it's good to see it again. So here we have this first one, y squared plus 2y over y squared minus 4. So we barely, this section, 1.6, they call it, don't they call it rational expressions or something? I forget what the name is on the official. I think it's rationals or rational expressions, something like that. That's a fancy word for fraction. Rational, ratio is one thing over the other. So, all right. So they want us to take these big old fractions with lots of letters and everything everywhere, and they want us to simplify. So how do we simplify that? We talked about last time.
We go through the transformer.
We just go in there and just cancel those y squareds.
You can't go up and down. You gotta go
Why not?
top to the bottom.
Why can't we go? Can we just cancel those?
No.
Why not?
That's a rule. You just leave it as a rule.
Yeah, Costco says no. Remember? Remember that rule from last time. I just want to bring that into your mind again. That's super important here and the rest of the course and all the other algebra courses you take. So, right, you can't, what do I mean Costco says no? What am I talking about? Someone want to remind me of the rule?
In Costco, you buy everything in bulk, like a
Bulk.
six-pack. But
And
like
what's...
Walmart, you have to do everything Walmart style.
And so what's the glue here? What's the connection? Pluses and minuses. Did we all catch that from my Costco talk? If this was, in other words, if this was y squared times 2y over y squared times negative 4, if they were times, you could totally do it. It'd be great. Right? So it's the pluses and the minuses that glue things together and make them a package deal. Meaning, if you want to cancel something from this y squared plus 2y, you cancel the whole thing or you cancel nothing. You can't just take the y squared part. It's all or nothing, like shopping at Costco, Sam's Club, package deal, right? Pluses and minuses glue things together. Why is that the case? Why did math make up that hard rule? That seems like just trying to make it hard.
No, because it makes sense.
It's true. Remember, we looked at an example, and I said, what about 4 plus 2? I don't remember what example I used. But what about 4 plus 2 over 2? What is that really, aside from all fancy math rules? Just really, what is it? What is 4 plus 2? 6. And what is 6 divided by 2? It's really 3, right? So if you cancel the 2's, is it okay?
No.
Clearly not. That would make it 4. You see, math is just saying what's true. You cannot cancel when things are plus. So you might be thinking, so in other words, if it was times, it would be okay? Absolutely. Let's see it. What is it really? What is really 4 times 2? 8. And what is really 8 divided by 2? So it's really 4. So is it okay to cancel the 2's?
No.
Yeah, because 4 is left. So see, it's right when there's a times. It's wrong when there's a plus. It's just a matter of a fact, isn't it? It's wrong when there's pluses and minuses. It just isn't so. All right, so we have to remember, it's not so obvious when they're x's and y's as it is when they're numbers, huh? So you have to remember that. All right, so that's the big overhead picture. So y squared plus 2y over y squared minus 4. So, again, we can't cancel. So what do we do then? So if we can't cancel, what do we do?
We make them something that can cancel.
Yeah, exactly, which is factoring. Because factoring makes them times, and then you can cancel. That's why we're so obsessed with factoring. That's why we did all that factoring work. All right, so let's factor the top first off. How do we factor that top?
Take out the y.
Yeah, what's the first question in every factoring problem? What's in common? And y is in common. They both have a y in common. What does that leave on the inside? Y times what will go back to y squared? Y. And y times what will go to 2y? Plus 2. Good. Now on the bottom, can we take it? What do they have in common? Nothing. Right? This one doesn't have a y back there, so they don't both have a y. There's no number they both have. The y squared in the front doesn't have any number at all. So that one doesn't, the bottom doesn't have any GCF, nothing in common. So what do you do? So that means we go to the 2 parentheses. Remember those kind? Yeah, this one, really, this comes from YY to 2, doesn't it? So remember how the 2 parenthesis factoring works? Front times front to make front. What times what makes y squared? Y times y. And last times last to make last. 2 times 2 makes 4. And how do you make negative 4?
One of them has to be
One positive, one negative, huh? Either order, put the negative first and the positive, doesn't matter.
Now since they're multiplied.
Yeah, now notice they're multiplied. See why we're obsessed with factoring? Because when you factor, now they're times, which means it's shopping at Walmart or Save Mart or where you can buy just one, right? So now, what can I cancel?
The y plus 2 up on top. Y plus
Yeah. See, I'm buying the whole package. I'm buying the y plus 2 glued package. That's fine.
You mix the drinks.
What's left? What's left over?
On top.
Just a y on the top and a y minus 2. You don't need the parentheses on the y minus 2 anymore. There's nothing to separate it from anymore. Can I cancel these y's?
No.
No, the bottom is a package deal, so all or nothing, and we can't take all, so we take nothing. So we're just done right there.
Now, I know in the homework, it looked like...
Sense other questions on that one? All right, so let's try x squared plus 10x plus 9.
Those are fun.
Oops, okay, so number 2 here. Go here where I can write it a little bigger for you. So number 2. So x squared plus 10x plus 9. And what was the bottom? Plus
16x, 63.
plus 63. All right, thank you. All right. So really it becomes two factoring problems, doesn't it? Factor the top, factor the bottom. Factor both the top and the bottom, and then cancel. So give it a try. All right. So the 2 parenthesis factoring. Right? Yeah, same thing on the bottom. So remember how we do the 2 parenthesis deal. So there's front times front to make front. Oh, I should have looked for GCF. There is none of those. Everybody see that? There's nothing in common to all 3 terms. They don't all have an X. Oh, I'm touching the screen again. They don't all have an X. There's no GCF there. So we go on to the 2 parentheses. So front times front. So X times X makes X squared. Okay. And now we need 2 numbers back here that make 9. What times what makes 9?
9 and 1.
Yeah, there's 3 times 3 or 9 times 1. How do we know which one we want?
10.
Yeah, 9 and 1 because we want them to add to be 10. Right? They have to multiply to be 9 and add to be 10. Good? Now the bottom, same kind of thing. So again, X is in the front. You know, front times front makes front. And last times last, yeah, to make 63.
9 and 7.
Yeah, 9 times 7. And you can guess. You'll get used to the pattern. They're always going to have something the same. So like if you don't have any idea, you should think, oh, I bet they're using a 9. Oh yeah, 9 times 7. You can just try that in your calculator. Do you get what I'm saying? If you're looking at that 63 and you're not sure, you should look up here and go, oh, there was a 9 on the top. I bet there's a 9 on the bottom. Take that 63, divide by 9, you'll get 7. You go, oh yeah, 9 and 7. Because that adds to be 16, doesn't it? Remember how it works? It multiplies to be the back number, adds to be the middle number. Plus 9, plus 7. Now that we've got it factored, now that it's multiplied, we can cancel. Cancel, cancel. X plus 1. No need to have parentheses. It's okay to have them, but they're not needed. There's nothing to separate it from anymore. And that's it. We can't cancel those X's because they're package deals, and so they just stop right there. All right, good? It's making sense. So it's just factoring, isn't it? So if you're good at factoring, these are just 2 factoring problems. All right, I'll move on if you're good. So number 3. So a little harder factoring now. 4x squared plus 13x plus 3 over 4x squared minus 3x minus 1. So now this one's going to be more tough. First, look for GCF. Is there anything in common to the 3 numbers on the top? 4, 13, and 3. Is anything going to all of those?
There's a 1.
We always have 1, so we don't count that one. Yeah, there's nothing, is there? So you know you're going to do the 2 parentheses, but this is for sure a tougher one, right? We're going to go front times front to make front, and we're going to go from there. It'd be good to come on down and do this one real quick. All right, so remember how we learned this is the harder kind. Oh, by the way, how do we know it's the harder kind? What's the harder kind? Number in the front. I don't know if you remember. The ones with the number in the front are much harder. So, okay, front times front to make front. So what times what makes 4x squared? There's 2 options, huh? 4 is 2 times 2. It's also 1 times 4. Both things multiply to be 4. There's 2 ways to multiply to be 4, huh? Well, how do you know which one's right? You guess. You don't know. Now, I did give you a bunch of hints, and but they're not hard, fast rules. Well, some were, some weren't. This one's not. I suggested that usually it's which pair? Remember that? The ones closer together. Yeah, so we should start with that pair. Now, that's going to be wrong, and it's not going to work on this problem. It's actually the other pair. But if you've foiled 10 million times, then you can see that right now. If you haven't, you just need to practice. And you just check. So usually the numbers closer together. Everybody understand what I'm saying? 2 and 2 are right next to each other, whereas 1 and 4 are further apart. It's usually the numbers closer together. This is an exception to that. So normally we would see, you can just watch me fail at it. It won't work. 2x and 2x, it's really going to be 4x and x. But supposedly right now I don't know. So 2x, 2x. Now front times front to make front. What comes next? Last times last to make last. What times what makes 3?
3 and 1.
Yeah, 3 and 1. No signs yet. Remember, I hold off on the signs. So is that right? Is that the right answer? It's not. How do I know it's not? Because I'm checking in my mind, because I've done this so many times. And if you can't just see it, that's okay. I couldn't at some point either. But I checked it 10 million times, and now I can. So you just got to check it. So take this first. Remember how we check it? First to both, second to both. Got to do the 4 multiplications, right? So you just simply got to do it. There is no shortcut. You have to just do it, unless you can do it in your mind, because you've done it so many times. So 2x times 2x? 4x squared. 2x times 1? 2x. Now it's the 3's turn. Now he's going to go to both. 3 times 2x? 6x. 3 times 1? 3. So ask yourself, it's all about the middle, right? Can the middle 2 make the middle from which we came? It's all about, we're trying to get back to that middle, right? Can 6 and 2, 2 and 6, somehow make 13? No way. No way. 6 and 2 add to be 8, they subtract to be 4. No way they're going to make 13. So that means something's wrong. How do I know what's wrong? Well, maybe I should switch the order and put the 1 here and the 3 there. No, that won't matter, because they're both with a 2x. It makes no difference. You'll get the same thing. So the problem must be back with the 2x, 2x. I must need to go with the other option, 1x, 4x. This is tedious, but the more you do it, you'll be able to see, and you'll be quick. But it just takes time. There is no shortcut. So, okay, so I'll go back and I'll go, all right, well, so I guess it's 4x regular x. Okay, so so that's front times front to make front. And now last times last to make last. What times what makes 3? 3 and 1. So I'll put the 3 here and the 1 there. This is the wrong order, it turns out. But I just know that because I'm doing it in my head. Let's check it. Remember, you just got to check it. Because the order on the back 2 matters when the front 2 are different. Right? Right now I've got the 3 next to a 4x and the 1 next to a regular x. If I switch them, it's going to change things. So we got to try both orders. I'm purposely doing it as badly as I can to show you the worst case scenario. So this 4x is going to go to both those. 4x squared, 4x. Notice no pluses or minuses. Those come at the end. And now it's the 3 going to both. 3x and 3. Can these 2 in the middle, remember it's all about the middle, can the 4 and the 3 somehow make the 13? No. They add to be 7. They subtract to be 1. No way. So right away, what do you do to try to fix it? Switch the order. Put the 1 there, the 3 there, and try it again. See how tedious this is? But you'll get faster if you don't skip this stuff. You just do it and do it and do it. You'll get faster. 4x times x is 4x squared. 4x times 3 is 12x. Now the 1 goes to both. 1x and 3. Oops. Can 12x and 1x make the middle? Yeah, there it is. Both positive. Now, did I tell you how the signs go? They swap. They swap, right? Well, they're both plus, so it doesn't matter really on this one. But this one goes there, and this one goes there. And that's the factoring. That's just the top. That's just half the problem. So that's 4x plus 1. And this is x plus 3. And then we go to the bottom. So now it's the same thing in the bottom. Let you do the bottom. So do the bottom, same kind of thing. You got to guess around. It could be 2x, 2x, could be 4x, regular x. Look what you got up top. You know what I would do? I would write that down immediately. I would go, I bet you it's 4x plus 1, and then whatever we need. That would be a wise first guess. That's how they write these problems. They usually make a match. So the top and the bottom will cross out. So it's probably 4x plus 1. Let that be your first guess. And try whatever front times front. So what would it be? If that's the case, front times front would need to be what? And
X plus minus 1.
X and right, because last times last to make last. Huh? So is that actually right?
Yes.
Let's check it and see. Unless you can see it already, because you've done this so many times. So the first to both, 4x squared minus 4x. This time we've already got the signs in there. And then the 1 to both, plus 1x minus 1. So that's minus 3x in the middle, isn't it? Is that correct? Yeah. That's it. That's perfect. That matches. So, yeah. So then we can cancel these guys. So all the hard work is the factoring. After that is child's play, huh? Just cancel what matches. So what's left over?
X minus 1 on top.
Or vice versa, right? X plus 3 on the top, x minus 1 on the bottom. And there we go. So the work is the factoring. Question?
Yeah, it's 30, that's why I'm
Okay, so on factoring, the first thing we look at is we look at these three, right? And we ask ourselves, is there something in common? Do they all have an x? No, the 80 doesn't have an x. Is there some number they all have? No, there's not. Okay, so then you go right to the 2. If there's nothing in common, if there was something in common, we would take it out and do the 1 big parenthesis, right? But if there's nothing in common, you just go right to the 2 parentheses. Okay, and then when we do the 2 parentheses, how do we work it out? Front times front to make front. That'd be x times x. And last times last to make last. See, I'm always doing that pattern. Front to make front. Last to make last. Now, what times what makes 80? And let's write multiply up here. You don't have to, but and add in the middle. Remember, you're looking for 2 numbers that multiply to be 80. Yeah.
Oh, I got a question. Oh, we're not there yet.
So far so good. This making sense?
I have a, oh, never mind.
So what numbers multiply to be 80? Yeah, 8. So for the 80, it's 8 times. You just use your calculator. Again, I'd really encourage you. You can't use a cell phone on the test, right? So if you show up on the test with a cell phone, I'm going to say, sorry. I gave you lots of warning, but now you're going to have to do it by hand. Can't have a cell phone because you could call out for answers, right? So make sure you have a calculator you're used to.
So next Tuesday's the test, right?
What's that?
Next Tuesday?
Yeah, a week from next Tuesday. So make sure, but don't, I wouldn't show up that day with a calculator you've never used before, right? You wouldn't show up at a ball game with a brand new glove you never used before, right? Break it in, get used to that calculator, know how it works on that. So anyway, so use your calculator. 8 times 10. Now, how do you know what signs go on the 8 and the 10? Yeah, remember it's all about the middle, exactly. Sign in the middle goes on the bigger. Remember that? Sign in the middle goes on the bigger. The 10 is the bigger. He's got to be the plus, the 8 is the minus, because plus 10 minus 8 is plus 2 in the middle. Is that good? All right, now the bottom. How do we factor x? Now the 2-termers are easy, aren't they? You just say front times front to be x squared, it's x and x. Last times last to be 64. 8 and 8, yeah. To be negative, it's 1 positive, 1 negative. We all good there? And now coming over here. Here's the 2 terms again. So 2 parentheses. Front times front to make x squared. And last times last to make 9. 3 and 3. How do you make negative 9? 1 positive, 1 negative. And then finally, coming down here, we have the 3 terms. There's nothing in common, so again we do the 2 parentheses. Front times front. Now, what two numbers multiply to be 30, right? Last times last multiplies to be 30, adds to be 13. 10 times 3 multiplies to be 30, adds to be 13. So use a calculator. If you're having trouble with that, just practice with your calculator so you can get those numbers. So both plus. All right. So now that we've got it all factored, that's the hard part. Now we just cancel anything that matches straight up and down or diagonal. Either way, it doesn't matter. So x plus 10, x plus 10. Oops. What else?
X minus 8.
Oh yeah, x minus 8, x minus 8.
X plus 3.
Oh yeah, x plus 3, x plus 3. So the only thing left, x minus 3 on the top, x plus 8 on the bottom. All right, what do you think on this one? Could I cancel stuff right now? Could I cancel, for example, this D with that D?
No.
Yes, you can, because it's multiple. It's not a package.
Right? This is not Costco. There's no pluses, or this is shopping at Save Mart. Right? There's just pluses and minuses. There's not pluses and minuses, right? Right? Remember, it's pluses and minuses that glue things together and make them a package deal. There's no pluses and minuses anywhere. So this is a nice, easy one. It's pluses and minuses that wreck algebra, that make everything hard. We'll see that again and again and again and again this semester. It's pluses and minuses that make things hard. So if there's no pluses and minuses, it's an easy problem. Just cancel out anything that matches. What else can I cancel?
That's it.
5 into 15?
Yeah.
3 times. Right? You can cross-cancel 5 into 15. It's totally fine. There's no package deals here. No glue. No pluses, no minuses. All right, so anyway, after all that canceling, what's left over? 3c times 3. I'm going to make that 9c in a second. Over y, which is 9c over y. Here's our answer. Everybody see what happened? I just took all the leftover stuff. On the top, a 3c and a 3, and a y in the bottom. 9c over y. So that was an easy one. What made that one easy? No pluses and minuses. Didn't have to factor, therefore. Yeah. Because there was no pluses and minuses. Good. Number 6.
So the top stays at the top when you're doing multiple. You go.
Yeah, that's right. That's right. Top stays in the top, bottom, yeah. Bottom stays in the bottom. Squared plus 5x.
Okay, just throw everybody off.
Minus 50. X plus 10 over 9x. All right, try that one. Canceling things right now? No. Can I cancel this x with this x?
No, because it's a package deal.
The bottom one's good, but the top one says, no, I'm a package. You either buy the whole x plus 10 or you don't buy any part of me, right? It's all or nothing with that x plus 10 up there. So no, we can't do that. Let's put it back the way it was. So what do we do instead? Factor, right? So you got to factor this and this, don't you? They both need to be factored. So factor them with the parentheses. I'm going to move ahead because I want to get through a lot with you. So x squared minus 25. I hope you're getting quick with that one. That's just x plus 5, x minus 5, right? And it doesn't matter what order. You can put the minus first, then the plus. That was a good question a little bit ago, right? The order doesn't matter. As long as you have one plus and one minus, either order. On the bottom, we're looking for two numbers that multiply to be 50. So what times what's 50? 10 and 5. And how do the signs, remember the trick on the signs? Sign in the middle goes on the bigger number. Plus goes on the 10. And the minus on the 5. Remember, the bigger number always gets the sign in the middle. The smaller number can go either way, right? Plus or minus. But the bigger number always takes the sign in the middle. And plus 10 minus 5 adds, remember the middle's all about adding, adds to be plus 5 in the middle, doesn't it? And they do multiply to be minus 50. So that's good factoring. All right. And then the back part, bring that down. X plus 10 over 9x. Okay, now we cancel what we can. What can we cancel?
A whole lot.
X plus 10s Oh, x minus 5. You can go straight up and down or diagonally. That's all good. That's it, huh? So x plus 5 on the top, 9x on the bottom. And that's as far as we can go. Is that good? Questions on that one? This one's going to be divide instead of multiply. Okay, so does anybody know already what?
Flip it.
Yeah. There's a saying some people use. Keep, change, flip. That might help you. Keep, change, flips. Because dividing is upside down multiplying, isn't it? Think with me for a second. Just do plain old numbers. I want to show you that it's truth. It's not just making up rules here. What is 10 divided by 2? It's 5. We all know that's 5, right? That's the same as 10 times what? A half, right? What's half of 10? 5. See, it's the same. Do you see that dividing is the same as multiplying by the upside down? Right? Dividing and multiplying are the same thing. They're just upside down of each other, aren't they? So whenever you're dividing, you can change it to multiplying if you flip the thing. See how that's true? Well, that's exactly what we're going to do here. We're going to flip the one at the right, and we're going to change to times, just like we did with those numbers. Instead of dividing by the number on the right, we're going to multiply by its upside down. The reciprocal, it's called. And the answer will be the same, won't it? And it's easier to multiply, so we'd prefer to do that. Just the one on the right. Good question. Just the one on the right, right? Because I didn't flip the 10, did I? I didn't flip the one on the left. It's just the one on the right. So that's why the saying becomes keep, change, flip. So when you're dividing, for dividing, keep, change, flip, meaning keep the one on the left the same. Keep it exactly the same. No changes at all. You don't flip it, in other words. And you change the middle from divide to times, right? Because it's going to become times. And then you flip the one on the right. Keep, change, flip, because dividing is just upside down multiplying. So just upside down multiply. And now we're back to multiplication. We just did like 6 of those. You know how to do multiplication of 2 fractions. Now that we're out of the dividing world and we changed it to times, you know how to do it, right? What do we do now?
Have some fun facts.
4 factoring problems. How quick are you getting to be? All right, I'm going to whip out some factoring here. So on the top, x is in the front. Remember, what we're looking for what multiplies to be 32, 8 times 4, and adds to be plus 4. How do the signs go? Sign in the middle automatically goes on the bigger one, right? The 8. The smaller one can be plus or minus, just depends on what it takes to make plus 4 in the middle. It needs to be minus 4, right? Because 8 minus 4 will make the plus 4 in the middle. All right. At the bottom, x squared minus 16. We've done a million of those. X minus 4, x plus 4, right? Times. Now, x squared minus 25, same thing. X plus 5, x minus 5. We've done a bunch of those. The bottom, 2 parentheses, x is the front. What multiplies to be 40 and adds to be 13? 8 and 5. Yeah, use your calculator if you're not sure. 8 and 5, both plus. That'll multiply to be 40, add to be 13 in the middle. There we go. Now we cancel whatever matches. X plus 5, x plus 5. X minus 4, x minus 4, x plus 8, x plus 8. Nice. So x, all that's left is x minus 5 over x plus 4. So that's hardly any different than the multiplying problems, right? Dividing is just upside down multiplying. You just keep, change, flip. Keep the one on the left the same, change to multiplication in the middle, flip the one on the right. Because dividing is just upside down multiplying. Okay, on we go. I'm going to skip 9. It's the same thing. We got to get to 10. We got bigger fish to fry here. To number 10 we go. So 6x minus 2 over 3 minus 5x plus 6 over 3. Okay, we just changed gears. We're subtracting fractions now. Right? We've been multiplying and dividing, which is just upside down multiplying, same thing. This is a complete and total shift. Things are going to radically change here. So we're moving into adding and subtracting. Now, what have I said already about adding and subtracting? Is it easier or harder in algebra? Harder. These will be much more difficult. Adding and subtracting is always way more difficult in every setting in algebra. When it comes to roots, when it comes to fractions, when it comes to everything we do in algebra, adding, subtracting is much more difficult than multiplying and dividing. All right, so how do we subtract two fractions? Got to have the same denominator, don't we? Well, luckily, these already do. In a minute, they won't. But right now, this one's not going to be too bad. They already have the same denominator. So you can just combine them into one big fraction. So go ahead and just put them together. Just combine all that into one big numerator. Can you do that real quick? So it's just going to be 6x minus 2. Just grab the first one. Minus 5x plus 6. And that's wrong, but that's a very common mistake, what I just did. So I do it so you won't. What did I just do that's wrong?
You made me write this down.
Yeah. This minus sign is subtracting both of those guys, isn't he? He's not just subtracting the front. So he's got to distribute here. You could do parentheses. I'd rather just skip that step, though, and just go straight to this. You see, that minus sign has to hit both of them. Super common mistake. When there's a subtraction in the middle, it has to hit both of these guys, not just the front part. You're subtracting the whole fraction on the right, not just the front part. Right? And so now we can combine things. Now it's just combine like terms. 6x minus 5x. Yeah, just x, 1x, or just x. Yeah. And minus 2 minus 6. Lose $2 and lose $6, you lost $8. Over 3. And we're done. That one wasn't bad because they had common denominators. Does that make sense? Questions I can answer?
How about if you want to do the 6x minus 2, can you do like 3?
What's that, Sabino?
Make it like a factor.
Oh, factor the 6x minus 2? Yeah, good question. We don't want to factor right now. Even though you're right, that those do factor. We don't want to factor right now. So yeah, so good question. Do everybody see what Sabino's saying? It's a really good question. So know the process. When it comes to, if these were times, if they were multiplying in the middle, that would be exactly what I would do. I would factor that one. I would need to factor, right? But they're not times. It's subtracting. So if it's adding and subtracting, you're not thinking about your first thought, your first order of business is common denominator. Common denominator. So we don't even move to factor. Good question. All right. So number 11. 1 over x plus 3 minus 1 over x plus 4. So we need to subtract those fractions. All right, so let me give you some steps here. Step number 1. Let's do this. Let me call it step number 0 because it's not really always there. I'm going to say never subtract. Instead, move the negative sign or the subtraction sign, same thing, to the upper right and distribute if needed. It's not needed in this case. Change to plus in the middle. A big step 0. What am I talking about? Take this minus sign right here and move him. That's a lot of fancy words to say. Move that minus sign to the upper right. It'll make it so much easier for you because people forget about the minus and it messes them up. So let me suggest that you never subtract. Instead, you move minus signs to the upper right. Let me show you why that's the case, what's going on there. Think about this with me, guys and gals. If I was going 7 minus 2, what's the answer to 7 minus 2? It's 5. How can I make that an adding problem with the same answer? 7 plus what? Negative 2. It's going to be the same thing, isn't it? Well, that's all we're doing. What I'm saying is instead of subtracting, add the opposite. It's the same result, and you won't tend to mess up. Does that make sense? Do you see what I'm suggesting? So I'm saying instead of subtracting two things, add the opposite. It's the same result, and you won't mess up the negatives. So I'm never going to subtract. Instead, this is going to come down and become adding, and this will be the opposite in the top. And the other one, just no change. Does everybody see what I'm saying there? And then this just comes down. No change. Let me give a little more room there.
You just gonna put -1 up there.
So add the opposite. So one more time, what happens? The minus in the middle moves to the upper right. See the arrow there? Moving it to the upper right. And then you change to plus. In other words, I'm adding -1
Okay, I got it.
instead of subtracting 1. It's the same effect, but putting the minus right there will help you to not forget it, which is so easy to do on that question.
On the bottom, do you want us to leave it in factor form or the simplified form?
In the end, we'll leave it factored.
Oh, okay.
Yeah, I think either way is fine. Probably they'll accept it either way. All right, so that's step 0. Step 1. Now we have to add those two fractions together, don't we? So how are we going to add those two fractions together?
Find a common denominator.
Yeah, but here's how you do it. You multiply top and bottom by the other denominator. So I'm going to take this x plus 4, the other denominator, and I'm going to multiply top and bottom of this fraction by the other denominator. And then I'm going to go over here and multiply top and bottom of this fraction by the opposite denominator, x plus 3. Why? Because that makes the two bottoms the same. See it? They both have the same two things now, don't they?
Yeah.
By giving them the other guy, both of them, now they're the same denominators. See how that works beautifully? To make the two denominators the same. And it's legal meaning in the sense that it doesn't change anything, because I'm doing the same thing on the top and the bottom, right, of each fraction. You with me on that? As long as you multiply the top and the bottom by the same thing, you're not really changing the fraction, are you? It'll look different afterwards, but it won't really be different. Right? Think about numbers. What if I have like 2/3 and I multiply the top and the bottom by like 2? It's going to become 4/6, which is the same as 2/3, isn't it? So when you multiply top and bottom by the same thing, you keep the fraction what it was, you just make it look different. And now, why are we into that? That'll make the bottoms the same. That'll give us common denominator, won't it? So that's how you do it. All right, so now what is the common denominator? Well, it's both of those. I'm just going to make one big fraction now. It doesn't matter what order. I could have put the x plus 3 first and then the x plus 4. It doesn't matter at all. Either order is good. It's just one big fraction now because their two denominators are the same. They're common. So that takes care of this and this. That's the denominators, huh? So now all we got to do is figure out the new top, the new numerator. How do we do it? Yeah, that 1 is going to multiply. By the way, notice, I'm not going to multiply the bottoms. I didn't take this and multiply out on the bottom. Why not? Because I want to leave the common. I'm happy with common denominator. The minute it's common denominator, I'm going to leave the bottom. So I'll write step 2. Multiply out the tops only. So multiply out the tops only. So this will be 1x plus 4, and then that minus 1, minus x minus 3. See what happened there? Multiply out the tops only. Gather like terms in the top. So multiply out the tops only and gather like terms in the top. So what happens in the top? We're going to gather like terms now. What happens with x and minus x? Cancel out. 4 minus 3? Just 1. Over x plus 4, x plus 3. Done.
I got a question there.
So when you type these answers in to, let me go to fresh screen and show. So we have the answer right now, right? 1 over x plus 4, what is it? X plus 3. Okay, let's think for a second about typing that into the computer. Okay, so if you type into the computer 1 divided by, let's just think about numbers for a minute, and then we'll get back to the x stuff. Notice how I always reason with numbers, and then I go to the x's, because that's harder, and x's are just numbers we don't know. So if I go x divided by 2 times 3, if you even type that into your calculator or computer, you might think that means 1 over 2 times 3, 1 over 6, but it does not. It means 1 over 2, this means dividing, times the 3. It doesn't know that extra 3 is in the denominator. It has no way of knowing. You have to communicate to it that fact. It just says, oh, you want me to take 1 divided by 2? Okay, I will. And then you want me to go times 3? All right, I will. And you go, oh, no, computer, calculator, I want the 2 and the 3 in the bottom. Well, you need to tell me, says the calculator or the computer. Well, how do you do it then? You go 1 divided by... Now, if you want 2 things to be in the same zone, like the denominator is a little world into itself, the denominator zone, you've got to take them and put an extra set of parentheses around them. Then the calculator will go, oh, it's 1 divided by, and the 2 and the 3 are both in the denominator. Then it'll know. Does that make sense? If you want more than one item in a certain zone, you got to put parentheses around it saying, hey, this group hangs together in the denominator. See the difference in that? See how those parentheses serve that function? So therefore, that is germane for how we type this in. How do we type this in then? 1 divided by parenthesis x plus 4, parenthesis x plus 3. Is that going to work right there? No. We need an extra set of parentheses.
Where?
This right here will not be right. You need an extra set. You need this and this. Are you seeing that? This is where I say this is not an easy class. This is not for the casual. Math never was. This is going to take time. Are you tracking with me on this? So why? Why was the other way not good? Because they were not grouped together. See, if I take these off, the x, there is nothing grouping the x plus 4, which I want to try to keep the color scheme consistent. There is nothing grouping the x plus 4 with the x plus 3 right now. You might say, yeah, we get those parentheses. No. What are those parentheses around? This set of parentheses right here groups the x with the 4.
Yeah.
Good. And this other set of parentheses groups the x with the 3. Great. But nothing groups the two of them together, which is what you need, since they're both in the bottom.
So if you don't do the double one, it'll look like you're factoring out the x squared minus x squared plus...
Yeah, it won't know they're both in the bottom. It'll just think the first one's in the bottom, and then the second, it'll think this. In fact, that's what that would mean. It's not just thinking it. That's what it means to write it that other way. That's not what you want, right? You want them both in the bottom. Does everybody see that?
So the double parentheses.
So you got to put another set of parentheses around it, double parentheses. That orange set is grouping the two parentheses together in the bottom. Do you see that? So that'll work. So I would do it that way instead of multiplying them out, because on the multiple choice exam we take, it'll you won't have to do all this. You'll just be grabbing the right option, but it'll look just like this. They'll be just like that.
Okay.
Does that make sense? Good
So
question.
brackets, so you also use brackets, because brackets.
Yeah, brackets are nice.
But
Yeah.
brackets work for that?
Yeah, brackets are exactly like parentheses. They're just a different style. They look different, function the same. I like them because that way it's easier to tell it apart. Yeah, do a bracket. The bracket, it'll work either way, bracket or parenthesis.
Okay.
Brackets are just a different look, so that's easier to see. Yeah, I like brackets. Good idea. All right, that makes sense then on that answer. So you'd have to type this in: 1 divided by bracket x. Let's do brackets. That's a good way to go. X plus 3, and then bracket. Those brackets tell the computer all that stuff is in the denominator. On that. All right, good. To number 12. Number 12. 1 over x squared plus 6x plus 8. Minus 1 over x squared minus 3x minus 10. Okay, so step 0. Remember what step 0 was? Never subtract. So what do I do?
Just you move the.
Take that minus, move it to the upper right, and change to adding. Add the opposite. Now, don't put the denominators yet. Let's go on to we have a new step 1 now. Sorry, this got a little more to it. They just added to the recipe.
So do I need to put it on my other notes for?
Nah, we'll build it up here. It's all good. See how on the last one, the bottoms were just, see how these denominators need to be factored?
Yeah.
Yeah.
But it's the same thing.
We just didn't have to factor the denominators in the last one. But yeah, otherwise it's the same. Factored the denoms. We didn't have to do that in the last one. So factor the denominators,
Is that a rule?
not the tops. You never factor the tops because those are going to combine later. We don't want to factor the tops, even though we wouldn't even think about it on this one. But never factor just the denominators. So let's factor those denominators. You guys are becoming lean, mean factoring machines now, right? So how do we factor this first one? X and X, front times front.
4 and 2.
Yep. What multiplies? Remember, it multiplies to be 8. 4 times 2. How do the signs go? Sign in the middle
For the bigger number.
always goes to the bigger, automatically, no exceptions. Now the other one, the smaller one, the 2, can be plus or minus depending on what you need to add to be the 6x. What do you need that 2 to be? Positive or negative? Positive, because plus 2 plus 4 is plus 6 in the middle, isn't it? And multiplies to be 8. Can you factor the other one? Don't say it out loud. Give everybody a chance on that one.
Oh,
Yes.
Gotta be 5 and 2. And how do the signs go? Sign in the middle? Always onto the bigger, automatically. And the other one can be plus or minus. What do you think? What does it need to be to make negative 3? Pause, right? Negative 5 plus 2 is negative 3 in the middle, isn't it? Perfect. Plus it matches the other one. See how we could have guessed. All right, now let me do step 2, and let me say it in a way that's a little different than I said it before. It's really the same thing, but it's a way more helpful now that it's more complex. Multiply top and bottom. Because we got to get common denominator, don't we? That's the main. That's what's driving us forward. Our mind should be got to make those bottoms match. Look at them. They're kind of the same, but not all the same. We got to make them match. That's the main thing when you're adding and subtracting fractions. The denominators must match. So multiply top and bottom by what is missing. What is missing? Give them what is missing. Now, what am I talking about? What is missing? What the other denominator has. You know? What I'm saying?
X plus 2.
Yeah, so look at this denominator and compare. So over here, top and bottom, I'm going to give him whatever he's missing that the other guy has. It's like looking at your neighbors and saying, what do they got? So we're doing what you shouldn't do. Looking at our neighbors, you're looking at the other denominator, saying, what does he have that I don't have? What am I missing? X minus 5, right? So you give it to him top and bottom. X minus 5, X minus 5.
So it's always going to be the right. Whatever you're doing on the right.
Oh, no, and then we're going to go to this guy also. And we're going to give him what the other guy has. That'd be like if my neighbor went and bought some family vans, and I bought a Mustang Shelby thing. So, what? I don't think he wants to do that. What does the other guy have that he doesn't have? X plus 4. You see, you're giving them what each other has to make them all the same. Right? We're trying to make all the denominators the same. Right? It's communistic philosophy. Make them all equal. Right? Just spread out the wealth equally. Right?
So when you do that, do you multiply or do you just put it under?
Yeah, good question. We're not going to actually multiply the bottoms because we just want to leave it. Once we got common denominator, we're done with the bottom. Yeah, so see how they match right now? See how this guy has all the same 3 pieces as that guy. We made the bottoms the same by giving them what the other guy had, what they were missing. Make sense? So now, don't even mess with the bottom. Just leave it just like it is. We're happy with it. But on the top, so now step 3, if you can track with my steps here. Now step 3 is multiply the tops and do the like term stuff. So now we're basically done with the bottoms. We're not going to do anything else with the bottom. Once you get common denominator, you're done with the bottoms. All the work now is in the top. Multiply those out, gather the like terms, clean it all up. All the work's in the top. So now, what do we do in the top? This 1 goes boom, boom. X minus 5. And this negative 1 goes boom, boom. Negative X minus 4. How we doing? This making sense?
So you can't cancel out the X, right?
We'll see. So, is everybody good to there? So I just multiplied the tops. So again, back to this last step. I gave them what they were missing, top and bottom. You gotta do top and bottom so you don't change anything, right? Make the 2 denominators have the same 3 pieces, common. Then I made it 1 big bar. I don't need 2 anymore. They're the same. So I made 1 big bar, multiplied out the tops. Now X cancels X, doesn't it? Right? That's just 1X minus 1X. And minus 5 and minus 4? Negative 9. Over X minus 5. X plus 4. X plus 2. We are done. How do you type that in to the program? You got to go minus 9 divided by, and you got to do the bracket because you got to group all these guys together, don't you? With a big old bracket. Or another parenthesis. Either one would work fine. All right. So let's try now. Let's see how you're doing. So this should be the same exact steps as last time. Oh, notice you don't have to do the step 0 this time. What am I talking about? What was step 0? Yeah, step 0 was never subtract. Well, it's not even a subtraction problem. That's why I called it step 0, because half the time you don't have to do it. So just start going. What's the first thing you need to do here?
You have fun with it.
You factor this denominator right here first. Right? Look back to the steps. Step 1, factor denominators, not tops. Right? Factor denominators, not tops. So step number 1, factor denoms. All right. Okay. So step 1 is factor denominators, right? So I'll do that. So this is X plus 5, X minus 5, right? So far, so good?
Yeah.
So I factor that denominator. That's step 1. Step 2, what is step 2? I hope you're writing these down. A lot of math is having written steps that you follow. Yeah. Multiply top and bottom by what is missing, right? Write this down. Use this as you're doing the homework, by what is missing. Multiply top and bottom by what is missing. So that's the most important step. So we come to this, remember that's parentheses, top and bottom kind of thing? So I come to this first one, and I say, remember that's comparing to your neighbors. Go buy what your neighbors have. Not a good plan, really. So look over there and say, what do my neighbors have that I don't have? Neighbors have an x plus 5 that I don't have. Got to do it top and bottom so we don't change anything. Now come to this second guy, right? And look back the other way. Right? Back over here. What does the other neighbor have? Yeah, he's got it all. He's the neighbor that's got it all. He doesn't need anything. Everybody see that? So that's a really important step. Right? We're filling in their gaps to make them the same. Right? This neighbor already has it all. Whereas this one needs x plus 5 top and bottom. Now they have the same denominators, don't they? Does that make sense? So the left denominator was missing the x plus 5, but the right denominator has everything that the left has. Pretty good. Does that make sense? You're just filling in their gaps to make them all the same. Right? You're sharing the wealth. It's basically communism, right? You're sharing the wealth. You're spreading it evenly.
So
Right?
basically, fill in the gaps for,
It's just a scribble. It wasn't anything. It was nothing.
basically fill in gaps for.
Now notice that the bottoms are the same, aren't they? So we're done with the bottom, aren't we? I'm just going to draw one big bar now,
I didn't do it.
like that. And now it's all about the top. The work on the bottom is over. See how the first two steps are all about the denominator? Factoring the denominator, giving the denominator what he's missing. And now step 3 is multiply the tops and then do the like terms. It's all about the top now. So that 5 goes boom, boom. 5x plus 25 plus. And then I just bring these guys down.
That's the trick. Don't forget about it.
I don't know why I do so much work.
How we doing? Is making sense? And now,
No, because there's a 1 in front of that.
Yeah, see, that's what I did wrong.
and now we combine on the top the like terms. So 5x and 1x is 6x. 25 minus 55? Oh, it's going to be an extra step. Okay. And then x plus 5. There's one more step on this one.
Oh, shoot,
X
I
minus
didn't
5.
realize that. No?
We good to here?
Yeah, good. I just need to remember that there's always an amount.
Yeah, you see that top? Very rarely they'll give you something in the top that can factor. So I don't usually mention it. I don't want to give you more than you need, but we need it. So step 4, factor. I'll say try, because usually it doesn't factor. Usually there's nothing going on up top. But try to factor the top and cancel if you can. Usually you can't. Normally we ignore it. Let me help you. And I would write these 4 steps on my 3. This would be the kind of thing I'd put on my 3x5 card for the exam next week. Is I would put like these steps and maybe one example problem. You know, you can definitely fit that in and put those different techniques of factoring I showed you. Right, I showed you one of each kind. Well, especially when we get to the practice exam. Then I'll be pointing as we go over the practice exam on Thursday. I'll be pointing out saying, you know, put this, see this, and you'll know exactly what the real exam is going to be like because it's exactly like the practice exam. So you'll know what to put on your card. Anyway, notice, just to help, notice this process begins with factoring and ends with factoring. It begins with factoring denominators. First 2 steps are about the denominators, and it ends with factoring the numerators. Steps 3 and 4 are all about the numerator. Notice that? You start by working on the bottoms, first 2 steps. Factoring is the first thing. And then steps 3 and 4 are all about the top, ends with factoring the top. It begins and ends with factoring. What does? Adding and subtracting fractions, which is what we're doing right now. All right, so last step, how do we factor that numerator? How do we factor this?
So the
take out a 6, right?
Okay, so
Leaves x minus 5,
but the bottom will stay the same.
But you know, controlling this is
right? And then we
So we're gonna
can
out.
cancel x minus 5, x minus 5. So the answer is 6 over x plus 5. That's our answer. When you type it into the computer,
So do this.
you type it in 6 divided by, can I just put x plus 5 like that? Yes. Because there's not a second parenthesis, is there, this time? That needs to be grouped together. That'll handle it. Right? That whole x plus 5 is the denominator. That's right. Right? Whereas, look at number 12. See, at number 12, we had 3 items in the denominator, 3 parenthesis items. So they needed to all be grouped together with a big old bracket, didn't they? To let the computer know they're all denominator. But if you just have one parenthesis down there, just one parenthesis is all you need. How we doing? All right, there's number 14. Same steps, but this one has the step 0, doesn't it? What's step 0?
Step 0, transform that thing.
Never subtract. Grab that minus and move it to the upper right. Add the opposite. Right, look back at the steps. Follow. Let's see it. So remember the steps. I really encourage you guys to write down the steps. They will help you. So step 1 is factor denoms. Just takes a second to write that over in the side. Let you know what's happening, right? I'm going to factor the denominators. Right? In fact, I should probably write it by what I'm doing. So there's right here. I'm going to go step 1. Factor denoms. Actually, having done that, I'm going to change my plan and scoot it over a little bit. There we go. So step 1, factor denoms. All right, so this denominator needs to be factored. 5 times 4, both plus, right? Because they multiply to be 20, add to be 9. That good? They have to multiply to be 20, add to be 9. If you're having trouble factoring that, you're in trouble. I don't want to say that in a mean way, but I want you to know where you're at. You need to master that. You must. You need to go back to those other sections and practice that parenthesis stuff with hours until you can just do it. Because everything else in this course will assume you can just instantaneously do that. And if it's constantly stopping you, it's ball game over. So you need to go back if you've not mastered the parenthesis factoring and get quick. It's just because they're going to be everywhere. They're going to be in everything we do from this point forward. You got to be able to do that. So that goes with everything we learn in math. It just builds. You got to learn it. All right. So we get to here now. What's the next step? Step 2: multiply top and bottom by what is missing. Multiply top and bottom by what is missing. Right. This is the what does my neighbor have? I don't have. So you go to this denominator. What is he missing that the other guy has? Nothing. He's got that x plus 4. Okay, what about the other guy? Who's missing something? How about that? This guy. And remember, we always do top and bottom of the same fraction, right? Top and bottom of the same fraction. And we give him what he's missing to make his denominator the same as the other guy. What's he missing? The x plus 5. Just give it to him top and bottom, like that.
I think that's what I got confused on.
So that makes sense. See how these two denominators have the same things now? That good? You make the denominators the same. Like if I went out and bought the fancy car. I still remember. I really don't care about cars, but all right. So the two denominators match now, don't they? All right. So now multiply top by what's missing. Step 3. Now, no, we're done with the bottoms, right? Remember, the first 2 steps are about the denominator. Now, turn your attention to the tops. Multiply the tops, not the bottoms, right? Once the bottoms are common, we're done with them. Multiply the tops and like terms. So, usually that's the last step. So, one big bar. X plus 5, x plus 4. All right? And then this top, he just comes down. There's nothing going on with him. But the other one, we got to multiply, don't we? So that'll be what? Minus 5x minus 25. Watch your signs there. Minus 25. Okay, and then gather the like terms on the top. So 3x minus 5x is minus 6. Minus 4 minus 25. You lose $4 and lose 25 bucks. You lost 29 bucks. X plus 5. X plus 4. We're done.
So when,
Plus?
I'd rather just move on, try to pursue, hit it.
That good? Yeah, that's a plus. Okay, look at that. That's a mess. You know what that's called? It's fractions over fractions, isn't it? The name of that is a complex fraction. That's technically called a complex fraction. Because it's fractions over fractions. So it's a complex fraction. And here's what you do about it. Step 1. Well, which is the main step. It's pretty much the only step. You multiply every term by the LCD over 1. So you multiply every term, top and bottom, by the LCD over 1. Okay? But what is the LCD? LCD stands for least common denominator. LCD is, how should I say it, is, I'm trying to say it in the simplest way without being technically incorrect. The LCD is
So it's not least common denominator?
1, it is.
Oh.
I'm trying to tell you what it is. LCD is one of each item, one of each of the items in denominators to the highest power showing. Okay. Trying to give you a definition that will handle all situations. So, as I look up at that original fractions over fractions, let's take a look at what things are under bars. This and this. Those are the denominators, right? Those are the only denominators. So I've got to take a simple x and an x squared and put them together somehow to make an LCD, a least common denominator. What is it? Well, it's one of each of the items, but to the highest power.
Oh, so it's x squared.
So it's just x squared, right? So you got x squared. You're just going to take the higher power. X squared. That's correct. All right, and what do I do with it? LCD over 1, meaning x squared over 1 to every term. So it's here. I'm just going to write x squared. There's no point in putting over 1. It's here. It's here. I will put it over 1 because it's next to a fraction. And it's here. See how I multiplied that x squared over 1, or just x squared, same thing, to all 4 terms. That's okay to do because I'm doing the same thing to the top and the bottom. See, I'm always doing that.
So LCD to all 4 terms.
LCD to all 4 terms. Exactly. There won't always be 4, but in this case, there's 4 terms. That's making sense so far?
I put every term.
Yeah. So now why are we even doing that? Well, we want to clean this thing up. This thing's ugly. Fractions over fractions, that's ugly.
So it's 2 over 1.
We're doing it to cancel denominators. So I'm going to come back here. Look at these guys. Totally cancels out, huh? What about up here?
So you use it to cancel the denominators.
Yeah.
Cancels to what?
This 1x in the bottom will cancel the 2 power, leaving 1 extra x, huh? Does that make sense? Because x squared was xx. So there's 1 left over.
Oh, yeah, it would be 14. Oh, okay.
Are we good there? Let me write that again.
So the top would be now 214, right? Yeah,
No.
it'd be
So this was x squared, meaning it was xx.
Right.
So one of these canceled one of these. The other one's left over, right? It's going to be 14x there.
Yeah.
Is that good? So what are we left with now? Now we have 2x squared right here plus, what do we have here? 14x over x squared times 1. And what's left here? Just the 49. Yeah, but everybody good to there? Yeah, we have one more step. Does everybody, we see how it's not fractions over fractions anymore? It's cleaner. It's just a normal fraction now. We got rid of the extra ugliness. We have one more step. You got to factor the top and the bottom now, don't you? But does everybody see that step? So you multiply all the terms by LCD over 1. Top and bottom, you're doing the same thing to the top and bottom, so you're not really changing anything. Just making it look better than it did. All right, now, how do we factor the top? So whenever we have a fraction, we factor on that.
Factor top
Miguel,
and bottom,
right? What's that?
Factor top and bottom, right?
Top and bottom. Yeah, because we got to get it to reduce. So how do we factor that top?
Take out 2x.
Yeah, take out 2x. Remember, take out what's in common. It's been a while since we've done one of those. When the first thing you try in factoring is take out what's in common. We haven't had one of those for a little bit, have we? I'm making sense?
Yeah.
And so what's that going to leave? 2x times x will go back to 2x squared. And 2x plus 7 will go back to 14x, won't it? See how I took out the GCF? Took out what's in common? 2x.
So the next step is GC.
So practice that. If that last section on factoring is not tight for you yet, spend some more time. Go back over it. You know, I opened it up so you can go back and practice. I clicked the review button this weekend. I got that all set up correctly. So you can go back and practice after you're done with it for extra practice. Is that what you're wanting to do? You're thinking, Mr. Hank, can we just do more homework? That's what I want. Maybe not. All right. All right, so now how do we factor the bottom?
It's a perfect square.
X plus 7, x minus 7. Yeah. I've done a bunch of those, right? And now what can we cancel? These guys, what are we left with? 2x, x minus 7. Done.
Yeah.
So, fractions over fractions. Complex fractions. What do we do to clean them up?
The LCD effect.
Yep. So, complex fraction. So, multiply LCD over 1, all the terms, huh? But what is the LCD here? 1 of each denominator piece, right? So it's like I'm going shopping. What if I say I'm going to go to Costco? Well, you can't do that at Costco. I'm going to go to Save Mart, and I'm going to buy one of everything. I'm going to buy one toothpaste, one mouthwash, one whatever, beef jerky, one whatever, right? I'm just going to go down the aisles, one of everything. So that's what we're doing with the denominator. We're buying one of everything. So 3, a 7, an x. We don't need the other x. We don't need both of them, right? Just one of everything. So the LCD is going to be 3 times 7 times x, better known as 21x. Does that make sense? That's how you find an LCD. One of every denominator piece.
21x over 1, right?
Yeah, and we do, right, over 1. So we go 21x over 1, 21x over 1, 21x over 1, 21x over 1. And then cross-cancel and multiply whatever's left over on that.
You put it.
Okay, I'm going to jump in. Time is running. I got to start that next section. So cancel this x, cancel this x. What's left over there? Right? What's left over right here? Just the 21. Here, 3 into 21. I encourage you to make it big. I don't have very neat writing at all, but I make it big so I can see everything. You don't have to have great writing, but you have to see everything. Don't write really tiny, and then you can't see stuff and you drop stuff. So 3 goes into 21 7 times. What's left over? 5 times 7, 35, and an X. Do you see that?
Oh, did I just miss a spot?
It's easy to miss stuff. Make it big.
Oh, I made it big, so.
On the
Top
bottom.
right corner, the 5, 3, what did you just do? Oh, okay.
The 3 went divided into 21 7 times. And then the 5 and the 7 multiplied.
Gotcha.
So we're cross-canceling or dividing, same thing.
Yeah.
X cancels X. 21 plus. Can you do that last one? 7 into 21 3 times. 3 times 4, 12x. Can we just cancel these 21s?
Oh, no.
Costco says no, right? It's glue, they're glued together, which means you buy the whole package or you buy none of it. You can't take part. So what do we do then? We could factor. There's no point. I'll do it anyway, though, because maybe you can't tell. You could factor the top, take out a 3. They have 3 in common. Leave 7. No, they don't. It has 7 in common, huh? What am I doing? Right, 7 goes into 21 and 35. Leaves 3 plus 5x. On the bottom, take out a 3 in common. Leaves 7 plus 4x. It was pointless. Why? Because nothing canceled. So either answer is totally fine. This is okay, or this is okay. Both are okay. Either one is just as good as the other. Why? Because you might think, well, I thought we had to factor. Factoring is only of benefit if it makes something cancel. Notice nothing ever canceled, nothing ever matched. So really, that last step was not needed. It didn't go anywhere. It was a dead end street. It's all right. You can just leave it that way. Or you can leave it the way that it was before. It's good either way.
So both answers are okay.
Both answers are acceptable.
Do you want us to practice what you just did with the factoring?
I better move on. So that's just the factoring we did before. So let's look at 18. 5 over x minus 1 minus 1 over x plus 1 all over x over x minus 1 plus 1 over x plus 1. All right, this is an ugly one too. All right, it's fractions over fractions, complex fraction. What do we do with fractions over fractions? We go shopping for the LCD, and we find the LCD, and we put LCD over 1 next to all the terms. So what's the LCD here? Look at the denominators. You're shopping the denominators, right? It's just the denominator. That's all we care about is the denominators, right? Least common denominator, right? We're only looking at denominators. So what do? You're shopping. You're going to buy 1 of each item. Not 2 of anything, just 1 of each item.
So x plus 1, x minus.
Yeah, either order. Doesn't matter. That's all it is, huh? That makes sense?
So the simplest answer is actually the same.
And so what do we do with that thing? Put it over 1 next to every term. X plus 1, x minus 1 over 1. 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 Good to there? That's what we always do with it, right? LCD over 1 next to all the terms. These are getting kind of ugly, huh? And then we cross-cancel whatever matches. So cross cancel whatever matches. So I'm going to cross cancel x minus 1 and x minus 1. What's left over in this term? 5 and x plus 1. Minus, then the next one. Cancel these x plus 1s. What's left over? 1 times x minus 1. Tracking with me? I know I'm moving fast. I need to go through the material. It'll be on YouTube. You can slow it down and watch it later. X minus 1s will cancel. X times x plus 1 plus, and the x plus 1s cancel. 1 times x minus 1. We good so far?
We don't have to put the 1, right? In front of the...
I think it'll help. You don't have to. You don't have to. But you have to remember that that minus is going to distribute. Whatever it takes for you to remember that. So, could I do this now? Can I just cancel these x minus 1s? Cancel these x plus 1s. Can't I? They're in parentheses.
No, because adding was
This right here and this right here say we are one big package. So you want to cancel us, you do one big cancellation for the whole numerator, or you don't do anything. Right. Costco is still here. So we cannot do that. Put it back the way it was. What do we do? Well, we got to gather like terms. Right? There's like terms here. So in other words, I got to multiply that 5. 5x plus 5. I got to multiply that minus 1. Minus x plus 1. I got to multiply that x. X squared plus x. I got to multiply that 1. Does that make sense there? Just multiply that all out. So what does that leave? 5x minus x, 4x, 5 plus 1, 6. What about the bottom? X plus x, 2x, plus 1. And we're done there. What did we do? We took a big old messy complex fraction, which was fractions over fractions, and broke it down to be a regular fraction.
Hold on.
We simplified it.
Maybe I might have missed something. I thought that x minus 1 went with the 1x. So how did you get
What's that?
No, you see how you went x 1 equals x minus 1, so...
Oh, yeah.
How do you get the fraction down on the bottom with x plus 1 still?
Here?
Yeah.
What's the
Yeah.
question?
How do you get that x plus 1 on the bottom, right?
This?
Yeah.
These guys cancel,
Right.
and the x... Oh, did I mess up?
Yeah.
Thank goodness. Oh, thank you.
No.
I was going crazy. Okay.
I'm going crazy. Thank you. That should be x minus 1, huh? Right here?
Oh,
No,
that's what happens when you
I
rush
got
through
the
things.
same answer down there.
No, that should be x minus 1.
Yeah.
Yep, I messed up. Yeah, no, it should be x. Yeah, it should be x minus 1. So this right here should be minus 1. Thank you, Dennis. Sorry, guys. Minus 1 there.
But isn't, you carry the negative to the 1, so that's negative 1, and that makes it a positive? Just two negatives at the very top. You know how it's negative?
about the top.
No, it's a,
No, on the
positive
very,
cancel out.
on the very top, right here, right there, negative 1 times x, and then negative 1 times negative 1 is positive 1.
Right, and I'm not talking about that.
Okay, what do you?
No,
I'm talking about this.
the bottom. The
Oh, okay.
Talking about these guys canceling and this coming here.
Okay.
Yeah. Right, so that should be x minus 1. So that would just be minus 1 there, huh? Everything else is good, I think. This is a hard one. don't forget your friend Costco, or your enemy, as the case may be here. Let me help you with this. So what's the LCD?
A squared.
We're shopping at Costco, or wherever,
Times.
and we're doing what? I said buy one of each type of thing, right? One of each. Keep that in your mind. So the LCD is one of each. So we got this, we got that. Those are the only denominators. So yeah, can you just use A plus H and that's good? No. An A plus H package is different than a solo A. You need A and A plus H because they're different. Because the A plus H is a glued package, and that's different than a solo A. Does that make sense? So you need them both. Over one. So, right? So you multiply those everywhere. Over one. So you go A times A plus H over 1. And A times A plus H over 1. And on the bottom, A times A plus... You don't need to do over 1 down there because it's not really a fraction down there. But you do have to do down there, right? You got to do the top and the bottom to keep the fraction the
So
same.
when we're rewriting these, when we're doing the test, is it best to just go ahead and start?
Questions being asked.
Yeah, you should
Why
make it
why
more
don't we
time.
use the H down there? Because it's not 1 over H. He's not a denominator. Even though you think, well, yeah, he's under, but yeah, I mean a local denominator. He's not under a little bar, right? Like, look back here. See how this guy was under a little bar, little bar, little bar, little bar? Right? This H is not under a little bar. So it's just all the items under little bars.
Is it better just to make, say, H over?
Okay, so A plus H. We'll cancel A plus H. So what's left over in this chunk?
That'd be
5A.
I was talking about the
Minus. And what's going to happen here?
It's gonna cancel out those.
Those A's will cancel. That'll be 5A plus H. Over. And what's on the bottom? All that stuff. H, A,
Oh,
A plus
okay.
H.
I see why you're saying to leave it alone. I got you. Because it's easier to write it just like that. Since the denominator's not a fraction.
Right, exactly. Denominator's not a fraction. Yeah.
Over one, when it's just going to drop the ones off.
That's right. Because it's not a fraction. Yeah, I only put stuff over 1 if it's interacting with a fraction. That's helpful when it's interacting. But if it's just hitting something that's not a fraction, I skip the over 1.
And I know since now it's since there's only 3 problems that we're having to do, I have to erase that middle fraction.
Okay, so now we have to finish the top. That minus 5 needs to distribute. Minus 5A, minus 5H. The bottom, I'm just going to leave it. I'm not going to multiply out the bottom. Why? That might be, I can see where that be kind of confusing for you. It's because the bottom is already factored and done.
Yeah, it's done.
It's done. Where you think, well, where's the top? No, I need to combine like terms still in the top. See how the 5A minus 5A is going to cancel? So what are we left with? Let me change colors for clarity here. We're left with minus 5H over H, A plus H. My A's always look like 9s. So we good to there?
Why wouldn't you just cancel A plus H, A plus H? Like, what's your reasoning?
Oh, good question. Yeah, right back here?
Yeah.
Yeah, why can't I cancel those? This guy said, right? Pluses and minuses outside of parentheses are Costco glue. And what they're saying to you is, you want to touch something up here? You buy the whole package, or you buy nothing at all. Right? It's the advice I give my daughters when they were young. If a young boy is interested in you, he can buy the whole package. That's called marriage, or nothing at all. That's what we do with pluses and minuses, right? They glue it. I changed the analogy dramatically there. The plus and the minuses, right? Good question. Now, are we done? Is this the final answer?
Yeah. No.
Are you guys, can we cancel these H's?
No.
No.
Are you so gun shy? Sure, we can cancel those. They're not glued,
We're down there at the bottom part, yeah.
right? They're not plus or minus next to anything. Are you so constricted by the Costco rules that you're afraid to cancel anything? No, they cancel. Right? There's, and it'll take off if you don't do that. There's off, right? Those guys are just times. It's all good, right? See the difference?
Why don't you distribute the bottom?
You could, but why? There's nothing wrong with it. Nothing beneficial to it. Yeah, we're done. We're done right there.